All right. Section 4 is talking about multiple argument properties. What? All right. So it's double angle identities, is what most books call them. So some more identities for you to memorize. We actually use these ones in calculus a lot, these double angle identities. All right. So, um, what are they? Well, sine of 2 times an angle will equal 2 times sine of A times cosine of A. Cosine of the double angle, 2 times A, there's actually 3 formulas that you can use. It's cosine squared minus sine squared, or if we replaced cosine squared with 1 minus sine squared using the Pythagorean identity, it's 1 minus 2 sine squared. Or I can also write them all in terms of cosines and make it 2 cosine squared minus 1. And then the last one, tangent of the double angle, is equal to 2 times tangent of A all over 1 minus tangent squared. So there we go. You're going to memorize those also. I don't think that your book has you prove them, but if you were to prove them, they're actually really easy to prove. You would, for all of them, you use the composite angles to prove them. The composite angle identities. So, for example, for sine of 2a, um, it's sine of a plus a. Wouldn't you agree that that's 2a is a plus a? But then this is sine of a plus b, right? Remember, it makes a sine, cosine, same sign sandwich. So it would be sine of the first times cosine of the second, same sign, plus cosine of the first and sine of the second. It just happens that they're both the same angle. Sine of a times cosine of a plus cosine a sine of a. Those are both the same terms. And so it becomes 2 times sine of a cosine of a. So just a side note, how do you prove them? You're going to, same thing with cosine of 2a. You would do cosine of a plus a, which is a cosine, cosine, sine, sine. Change the sign in the middle. That's how you get the cosine squared minus sine squared. And same thing with tangent. It's a tangent of a plus another tangent of a. And then anyway, so totally matches up with all of the composite angle identities. All right, let's show that the double angle identity works by substituting A is equal to 30 degrees. All right, now obviously this is not a proof. How you would prove these identities is by doing this, right? But we're just going to show that for 30 degrees it works. So let's, I guess we're going to do cosine, but I'm going to show that cosine of 2a is equal to cosine squared of a minus sine squared of a. And I'm going to show that it's true for when a is equal to 30 degrees. All right, so I'm plugging in a 30 degrees into all of these a's. So we got left-hand side would be cosine of 2 times 30 degrees. Is that equal to cosine squared of 30 degrees minus sine squared of 30 degrees? All right. Well, 2 times 30 is 60. So this left-hand side becomes cosine of 60 degrees. And is that equal to, keep in mind that what this means is cosine of 30 degrees quantity squared. Remember, that's what that means, when they put the square on the cosine there. And same thing here. This is sine of 30 degrees quantity squared. Okay. So what's cosine of 60 degrees? All right, well, 60 degrees is the tall triangle, which makes this side rad 3 over 2 and this side 1/2. And so cosine of 60 degrees is 1/2. So my left-hand side will be 1/2. Is that equal to, both of these are 30 degrees. So let's do a 30-degree angle. That's a shorty. So that's a 1/2 here, a rad 3 over 2 here, and a 1. So cosine of 30 degrees is rad 3 over 2. And then we're going to square it and subtract from it. Sine of 30 degrees is 1/2. We'll square that. So is that equal? Well, when you square rad 3 over 2, it's rad 3 times rad 3, which is 3. And 2 times 2 is 4. And when you square 1/2, it's 1 times 1 is 1. And 2 times 2 is 4. And that's a, what, a 2 over 4. Yep, true. Yay. Okay. Because 1/2 is equal to 1/2. Because 2 over 4 is 1/2. All right. Not too bad, right? Let's do another one. Same directions, but this time I'm going to show you that it's true for sine of 2a if a is pi over 4. Oh. So remember, sine of 2a, the formula is, or the identity is 2 times sine of a times cosine of a. And I'm going to plug in a pi over 4 for each of these a's. So this is sine of 2 times pi over 4 is equal to 2 times sine of pi over 4 times cosine of pi over 4. All right. When you multiply 2 times pi over 4, that becomes sine of pi over 2. And is this equal to 2 times pi over 4 is 45 degrees. So that's my favorite angle because I don't have to remember. Is it rad 3 over 2 or 1/2? No, they're both rad 2 over 2. Nice. Okay. Well, what's sine of pi over 2? Pi over 2 is 90 degrees. That's up here. And sine is the y value, so it's a 1. So is 1 equal to, this is 2 times rad 2 times rad 2 is 2. And 2 times 2 is 4. And it's like a 2 over 1, if that makes sense. 2 over 1. That. All right, well, that's 4 over 4. Yep, yep. Yay. All right. So we got those. Let's do a different type of question now. So those were just confirming, right, that our identities work for those specific angles. Let's now look at, if I give you that cosine of an angle is -3 over 5, and I tell you that the angle A, right, because that's the angle, that it terminates in quadrant 2. They want me to find sine of 2a, cosine of 2a, and tangent of 2a. So they want me to find all three of those things. Okay, so in order to find those, I need, so these are 2a's, right? It's double angle. Thank you. Notice that when a was 30 up here, 2a was 60 degrees. Yeah, so that's what they're making a comparison between an angle and an angle that's double the size. Okay, so yeah. All right, so what we need to know is I was given cosine of a, but I need to know sine of a also. So I need to find the other information of this triangle. It's telling me angle A terminates in quadrant 2. So this is quadrant 2, so I'll draw a triangle there. They're telling me cosine of A is -3 over 5. Well, that's x over r. So I know my r is 5, my x is 3. It's a negative though, so which one's the negative? Well, r is always positive, which makes it's your x that is a -3. This is obviously a 3, 4, 5 triangle, so I know that the y value is 4. But if it's not an obvious one, use Pythagorean theorem to find that missing side. Okay, so what does that mean? That means that I've got sine of a is y over r, so positive 4 over 5. Cosine of a is x over r, which they also gave it to me too. That's okay, I'm just going to rewrite it again. And then tangent of a is y over x, so a 4 over -3. And we always just stick it out front like that, or stick it up top, either one. Okay, so let's start with, they want me to find sine of 2a. Well, the identity says it's 2 times sine of a times cosine of a. So that's a 2 times sine of A was 4 over 5, cosine of A was negative 3 over 5. Do like a over 1, and you go top times top times top. So 2 times 4 is 8, times negative 3 is negative 24, and 1 times 5 is 25. So sine of 2 times the angle will equal negative 24 over 25. Cosine of 2 times the angle. You have 3 identities you can use, and any of them will work, but I'll just use the first one, just practice. All right, so this is equal to, remember this is cosine of A squared and then sine of A squared. So cosine of A was a negative 3 over 5. Sine of A was 4 over 5. We got those. And then when we square this, you're squaring that negative, makes it a positive. 3 squared is 9. 5 squared is 25. Got the minus sign there. 4 squared is 16. 5 squared is 25. And then 9 minus 16, of course, is negative 7. And then over 25. So there's cosine of the double angle. Got one more. I need to do tangent of the double angle. And so tangent of 2A is 2 times tangent of A all over 1 minus tangent squared. Okay, so that's 2 times, we figured out tangent of A was negative 4/3, all over 1 minus tangent of A squared, and that was negative 4/3. Okay, well that becomes a, this is like a 2 over 1, so this is a negative 8 over 3 over 1 minus, when you square that negative, it is positive, so that's a positive 16 over 9. Yeah. Well, if you get a common denominator, that's like a 9 over 9. So I still have negative 8 over 3. This is like 9 over 9 minus 16 over 9, being a common denominator. So then that's negative 8/3 divided by 9 minus 16 is a negative 7 over 9. Okay. Which then, the negative with the negative cancels. How about if we multiply by the reciprocal? So I've got, it's a negative 8/3, and then times, I'll do the reciprocal of the bottom, a negative 9 over 7. So obviously the negatives cancel. 3 goes into 9, well, 3 times. So 8 times 3 is 24 over 7. Okay. Now, keep in mind, it should work out to where I use the formula for tangent, right? But tangent's also sine over cosine, so confirm yourself. Negative 24 over 25 divided by negative 7 over 25. The 25s would cancel. The negatives cancel. 24 over 7. 24 over 7. We just probably won't ask you for all 3 in the same problem, so that's why I went ahead and showed you like actually using the formula for tangent. But you can definitely double check yourself that since tangent is equal to sine over cosine. Okay, let's do a proving. Yes, prove that sine of 2 times phi, that's another letter for an angle, is equal to 2 times cotangent of phi times sine squared of phi. If you want to change your letters, change your letters. I don't care. Next year, you're going to have to keep them, but you already got a lot on your plate this year, right? You don't need to worry about these crazy Greek letters on top of it. Okay. Which side looks more complicated? Definitely the right-hand side looks more complicated. Yeah. All right, so I'm going to write this as, I've got a 2 in front. It's like 2 over 1 times cotangent would be cosine over sine. You should know that identity. And then sine squared, and that's like a sine squared over 1. So this sine on bottom will cancel with one of the signs on top. So you're left with a 2 cosine phi sine of phi. Yeah. And that's an identity from today because it's equivalent to, 2 times 3 is the same as 3 times 2, right? So this is the same thing as 2 times sine of phi cosine of phi, and that's equal to sine of 2 times that angle. Ta-da! Not bad. All right, how about let's prove that tangent of y is equal to sine of 2y divided by 1 plus cosine of 2y. Okay, well, definitely working on the right-hand side because that's the more complicated side. Notice that both of these guys are double angles, right? 2y, cosine of 2y versus t on the left-hand side is just one angle, right? Just, it's not the double angle, it's the regular one. So let's use the identities, right? For sine of 2 times an angle, there's only one identity. It would be 2 times sine of y times cosine of y. Oh, look, cozy. Oh, cute. All right. On the bottom, I've got a 1 plus, and then cosine of 2 times y. All right, so I've got identities for the cosine of a double angle. There's 3 of them, right? Pulling back up. Here we go. I've got 3 identities, 1, 2, or 3. You can use any of them, right? But, and it'll work. Any of them will work. It's just some of them will require for you to do more work to simplify it, to get it looking the way you need it to. And others will, or one, will make it go directly to what you need it to be. So how do I know which one to choose? I want tangent of y. Remember, you always keep your eye on the goal. Eye on the goal, right? I want tangent of y. What I know about tangent is it's sine over cosine. So what I need in the end is a sine of y divided by cosine of y. So right now I have a 2 times sine of y times cosine of y, right? So what I really want to have happen is I want to keep this sine up top. I want to get rid of the cosine that's up top there. I also want to get rid of the 2, but I don't know how that's going to happen yet. But I do know this. I know I need to get rid of the cosine that's up top. So if I use this one, I will have a cosine in the bottom that I'm fingers crossed that it'll cancel with. Okay, so that's my goal. I could use any of the 3, but if I use either of these 2, you will end up having to rewrite them so that they end up looking like this. So if you had this up top, but you wanted a sine in the bottom, then I would have used the second one there. More rare that we use this one because usually you want to cancel things. So sometimes, but not always. All right, so this is the identity I'm going to replace the cosine of 2y with. I'm going to replace it with 2 cosine squared minus 1. So this becomes a 2 cosine squared of y minus 1. Okay. I know it was a big, dark, scary tunnel. Hopefully you're seeing a little bit of light at the end of the tunnel. You see, maybe not yet. 1 minus 1, those guys cancel. Okay. So now you're left with I'll write it, just make it more clear. So if the 1 and the minus 1 cancel, then you're left with a 2 times sine of y times cosine of y over 2 times cosine squared of y. Is the light getting brighter? Bright. Oh, a bright light. Okay, 2's cancel. Is it brighter? I hope it's getting bright. I hope it's shining bright. Yes? Shine bright like a diamond. Do you see now? I got a cosine up top, and cosine squared is cosine times cosine. So the cosine up top will cancel with one of the cosines down below, and you are left with sine of y divided by cosine of y. You got to be blinded now, right? Blinded by the light. Boop, boop. Yes? Yay? Hopefully. Hopefully you had to put sunglasses on because the light was so bright. You just needed sunglasses. All right, well, let's do one more because I know they're tough. I know they are. But they're a little bit fun. Yeah, well, maybe you don't think they're fun yet. But once you get to the point where you have practiced them enough that you actually get that feeling of, oh my gosh, I see it. I see it. I see the light. It's very satisfying. That's all I gotta say. I think it's fun. But whatever. Okay, let's prove this guy that cosine squared is equal to 1/2 of 1 plus cosine of 2 theta. Well, they'll both look pretty complicated, right? But I would say that the right-hand side is more complicated, especially, here's your clue. You've got identities to turn double angles into single angles, right? So if you've got a double angle in this identity that they're asking you to prove, use the double angle identities, right? So I'm going to work on this side. It would be a 1/2 times 1 plus, all right, cosine of 2 theta. You've got 3 identities to choose from. I'll show them again, right? This one, and this one. They're all correct to use. It's just if you don't choose the right one, you'll have to do more work, right? So which one am I going to choose? Well, I look at my goal. My goal is to only be in terms of cosine squared. So out of the 3 identities, this one has a cosine squared and a sine squared. This one only has a sine squared, but this one has cosine squared only, right? Not also a sine squared. So that's the one I'm going to use. So that's a 2 cosine squared of theta minus 1. 2 times theta and cosine squared, 2 different things, right? This is taking your cosine value and squaring it. This is taking your angle and doubling it. So like if it was cosine of 30 degrees, up here, this would turn into cosine of 60 degrees. Here, you would go cosine of 30, which is rad 3 over 2, and then square it, so it becomes 3 over 4. All right, so, well, let's see. I just want you to look at it. Just look at it, and please tell me that you see a light. Do you see a little light? I hope so. Let's simplify inside the parentheses first, right? 1 minus 1. You got a 1/2 times 2 cosine squared. You have to be blinded now, right? Put on those sunglasses. Put them on. Put the shades on. 1/2 times 2. Da, 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 da. Love it. Love it when a plan comes together. All right. I hope you all are having a fantabulous day. Bye.